So have you ever seen this before? I've gotten this comment a lot on my videos. People ask me like, hey Dave, why don't you use this line? Or why don't you use bash strict mode, bash in strict mode? Or why don't you use the unofficial bash strict mode? I've mentioned a couple different times that I don't use this. Today I want to dedicate a whole video to explaining what this is, why it works the way it works, and kind of why I stay away from it. So let's jump into it. All right, so to get started, here's the blog post. I believe this is where it originated from. Use bash strict mode unless you love debugging, and you can see there are two lines here. I usually only see this top line. I actually don't remember this bottom line being there, so that's pretty cool. But the top line, people comment this all the time, and as a bonus, we're going to talk about this. I couldn't find an actual date of when this blog post was posted, but on this page from the bash FAQ on the wholedge wiki, it actually mentions this. This is a really good page. I would definitely recommend going to read it. I'll link it below. But there's where it talks about the so-called strict mode and in the mid 2010s. Now this is important. The reason it's important is because I have a video on my channel called Why Bash. I go into like why I started learning bash, when I started learning bash. I started learning bash around 2010. I'll give you a quick little synopsis. I started learning around 2010. This blog post wasn't there. I don't know when this blog post was written, but it was sometime after I started learning. And I started learning bash really heavily using this website. So a lot of my opinions are informed from this website. Yes, I've done work and research and looked into this stuff, but like my opinions usually line up a lot with the opinions here. In fact, typically if you see Gray Cat's opinion somewhere, I pretty much tend to agree with it. I think, never met this person, but we have a lot of similar ways of thinking about things, at least from what I can see here. I could be totally wrong. But the reason I bring this up is because my opinion is going to be colored a little bit from having learned from this page. So if you want to go read this page, there's a ton here. I'm not going to dive into all of it. I'm just going to break down what strict mode is and show what it is, some of the pitfalls with it, and kind of why I stay away from it. So yeah, I guess let's pull up the terminal and jump in. All right, so we got this here. We have bash strict mode, and I have a couple directories set up. So we're gonna go through it one by one. So if you remember, the strict mode was what? set-e-u-o pipefail. There's a couple different ways to break this down. We have set e, set u, and set-o pipefail. So we'll go through it one by one, and then we'll check the IFS section later. So let's go on the first one, set minus e. So in here, what we have is we have a bunch of different scripts. We'll start with the first one, 0, 0. This is our count simple script. This is not set e, so this is no strict mode going on here. We have a very basic for loop. For I equals 0, I less than 10, I plus plus, we print I equals whatever, and then we print done. Okay, very simple. We run this. We iterate 10 times from 0 to 9 and it works. Awesome, right? Let's go to example 1 here, 0, 1. We do the same thing, but this time with set minus e set. So we run this and it works just the same. Hey, I tricked you. You thought something bad was going to happen, right? No, it works just the same. So that's really good. We haven't caught an error yet. Let's talk about an alternative syntax that you might use. I tend to write my for loops that way, but I know other people might have code like this. You can take a for loop, you can turn it into a while loop. Maybe this is slightly contrived, but you'll probably have code similar to this where you have a variable up here. While this condition is true, you increment it here. Maybe you conditionally increment it, blah, blah, blah. We could turn a for loop into a while loop like this, and this is totally valid, right? I equals 0, I less than 10, I plus plus. Let's go ahead and run this. This is our simple example, no strict mode, and it works. Hey, that's awesome, right? Let's look at the next one, 03. This is the alternate syntax, but we have the set minus e here. So let's go ahead and run that and see what happens. We get I equals 0, and then what happens? It fails. We return with an error code. So right off the bat, I want to jump in and talk about this. The reason I don't like the bash strict mode is because when it fails, it's very hard to understand why it fails. I know why it fails. I have a lot of bash under my belt, but if you were just getting started and you set this, this is a very hard problem to debug, okay? This is what I don't like about bash strict mode. I think it can catch a lot of issues, but the issues that it doesn't catch, you need to really know your stuff to understand what's going on here. This example is not super hard to understand. I'll hold your hand, I'll walk you through it. So we have I equals 0, and then we have this syntax right here where we do I plus plus. So we can do this on the terminal here. I equals 0, I plus plus, and now if we echo I, it's 1. That makes sense, right? What happened with I plus plus? Let's go ahead, let's reset this to 0. And then let's do I plus plus. That has an exit code. That arithmetic expression actually returned a code, and it returned 1. Technically a failure. That's what triggered the set minus e to fail. That's super weird, right? What if we do it again? Well, that time it didn't fail. Why didn't it fail? Whether this fails or not depends on what the number is in here. And there's some weird little gotchas with this, okay? Let's take a look at the script. I have manually unrolled the loop and made it as verbose as possible. We put our strict mode up here, and then we set I, we print what we're trying to do, then we increment it, and then we print worked. Then we set it to -1. Technically, it should already be -1, but we're resetting it here. We're doing everything as the highest possible verbosity here. Then we do this, then we do this. Okay, cool. Let's go ahead and run this and see what happens. I equals -2, it worked. When I equals -1, it worked. When I equals 0, it fails. Isn't that confusing? That's because this expression returns something. So if we have, let's say, 2 plus 2 in here, we're not saving this anywhere. We just ran that. That returned 0, meaning success. So we could do something like this. That was successful. 2 plus 2 is successful. 2 minus 2? That's not successful because the answer is 0. When the answer is 0, we have a failure return code. When the answer is non-zero, we have a 0 or a success return code. Even if it's negative, even if we put like -50 here, it's not 0, so it's technically a success. That's what's happening here. And then to add insult to injury, we're doing the post increment here. So it doesn't look at what the number has become. It looks at what the number originally was because the increment technically happens after. So if we were to set this to 0, and then increment it, we can see that there was a failure there. If we were to set this to -1 and then pre-increment it, we can see that there's also a failure there. That's very hard to debug. If you're learning Bash and you think you're going to set this strict mode and you're like, oh, this will help me, I think this will hurt you if you encounter situations like this because you won't know easily how to navigate yourself out of them. I have another example. Again, I won't go through all the examples on the website, but I have an example here. This is something I see a lot of people hit. I've hit this myself in the past. Let's go ahead and look at this example. We set our strict mode up here. We define two functions, my safe func and my unsafe func. Okay, very simple names. We call those two functions and then we echo done. So what's happening in this function? We set output equal to the command false. The command false will fail. By definition, it'll return a non-zero exit code, and we will store the standard out. There won't be any standard out, but we're just going to print when it's done. Then here, we define the variable, and we assign the variable on two separate lines, whereas here, we define and assign on one line. So let's go ahead and run this and see what happens. My safe func was done. We got nothing else. So my safe func, this one runs, this one does not run. What happens here? This, even though false is not successful, we're not getting the exit code of false. It's being masked. We're getting the exit code of the local keyword being able to assign a variable. So local was successfully able to assign the variable, and that's why we get an exit code of 0. Here, this was successfully able, probably, to create a local variable. This exit 0. This, the exit code is the command that runs in here. That's non-zero, so we break. We break right at this point. My unsafe function runs, but we never actually finish it. We could prove that. We could do bash -x on it, and this will run everything we do, or everything that happens. So we can see that we start the my unsafe func, we declare the output, we run false. There's two pluses here because it's running inside a subshell. There's a fork and exec happening here. And then we have this. That's it. So nothing's happening here. It failed. So that's wild. That's what happens with set -e. That's why I stay away from set -e. Okay, so what's next? We have set-o pipefail. So pipefail is super interesting. Pipefail is kind of useful. Have you ever had a command where it's like, you know, my super long command? It's a whole big command change, and then you want to pipe to grep for foo. Well, you don't actually care if any of these work or not. You only care about the exit code of grep because you want to see if something's there or not. You can just check $? Because $? will have the exit code of the last thing in a pipe chain. That's super useful, but the problem is, what if you cared about if these things fail or not? If these things fail, you won't actually be able to detect it with bash how it normally runs without looking at like the pipe status array variable. Because of that, we can set -o pipefail. And that way, if any one of these commands fail, it will stop right there. It will consider that an error. Let me stop right there. It won't stop. It will just return that failure as $? If you pair that with set -e, then it will fail. But set -o pipefail on its own won't actually stop execution. It will just return a failure if any command in the pipeline fails. So let's show what happens here. Here's a very simple example, contrived example. We're piping cat into head. You normally wouldn't do something like this, but this is just to show this could be coming from anywhere. This could be coming from curl or from a command or from a function. We set pipefail here, so we turn it on. We cat etc password, and we grab the first line of etc password. So let's go ahead. Let's run that. We get the first line of my etc password file, which is just comments, and it was successful. Hey, that's awesome. That's really cool. What about the large input? Same exact thing, but this time we're catting user shared dict words. This is a large list of words that exists on my system. Your system might have it too. User share dict words. You can see there are 235,000 words in this file. So we have very large input. We're piping to head minus n1. We want the first line from this file. So let's go ahead and run this. We get the first line. It prints it. That's great. It's a failure. It's a failure. Why is it a failure? I'll give you a hint. It's not head that failed. It is cat that failed. So why did cat fail? Let's dig into this a little bit. We have 141 here. Do you know what's going on? The shell's actually giving us that exit code that's not coming from the process itself. It's actually coming, well, it's coming from the exit status of the process, not the exit code of the process. The process was killed with the signal. We know that because it's above 128. I will show this. We can take, was it 141 minus 128, and we are left with 13. That means this process died from signal 13. We can do trap minus L to list all of the signals. We can find signal 13, sig pipe. So what happened in this example is that cat was killed with sig pipe. You may have seen this in programs of yourself when you're piping it to grep or head or tail or something like that. Basically, cat is just trying to spew bytes. It's just reading that file and writing it. And head says, you know what? I already got the first line. I don't need any of the data there, so I'm going to exit. I'm going to close at my input. I don't need to read any more input. So it closes it, and cat says, whoa, hold on, my writer just disconnected. I can't write to this anymore. Sig pipe. It dies. It tries to write to it, and it can't. So that's what's happening there. With pipefail set, if you had this also with set minus E, you're done. That script is done. And this is a very difficult problem to figure out. How would you figure this out? I knew how to take 143, 141, I don't remember, subtract 128, look at trap minus L. But if you were just getting started, how would you debug this? That'd be very tough to debug. And that's why I'm worried about this strict mode. All right, so what do we have next? We have set minus U. I will tell you right off the bat, this one is the least scary. In fact, I've looked at this one and I'm like, oh man, this would be useful. I actually kind of want to start turning it on some of my scripts, maybe during development work. There are still some gotchas with it, and definitely gotchas if you're not sure if your script's going to be used by other versions of Bash, because there's some weirdness with that. I'll show you. So let's go ahead and let's jump into it first. We have our simple script here where we say foo equals 1, bar equals 2, and then we echo foo equals $foo, $bar, $baz. Uh-oh, we never defined that. What's going to happen with Bash? Well, it's fine. Bash just expands that to nothing, and it works. It works just the same. It works successfully. That's awesome. What about if we set minus U? I should have had that there. If we set minus U and we run the exact same script, what happens now? Look at that. This is a super nice error message. I have to say, I actually really like this. Line 10, baz, unbound variable, and then it dies. The script dies. That's actually really cool. We tried to take a variable that wasn't set, so if you had a typo or something, this would catch that. That's super useful. Are there ways to break this? Absolutely, there are. Let's talk about this. So let's look at this example. We set minus U, so we turn this option on. We declare an empty array, and then we loop over all the items in the array, and we print them, and then we echo done. Remember, it's an empty array, so there should be no items in it, so it should just print done. That's awesome. This was successful. This works how we expected it to. We are on Bash version 5.3.3. What if we weren't? What if we were on an old version of Bash? What if we were on the one that shipped with my Mac, 3.2.57, and we were to run this script? What would happen? Well, we get an unbound variable. You get unbound variables with unset or empty arrays. There's some weirdness around this, and it changes between like version 4.2 and 4.3. So as you can see, this one breaks, but it breaks on very old versions of Bash. Going forward, it's probably safer to use. The reason I would say I would stay away from it is because I don't know what version of Bash people are going to be running this on. I will say though, if you want this functionality yourself, like look at this first example right here. If you want to just during development test, Bash minus U, all those options can be passed here, this, and then you get that behavior. So during development work, I would say use something like this. In fact, I'm going to start putting it into my workflow. You could also use shell check. I love shell check. It's really great. I should talk about it more on this channel. I kind of fight it sometimes. It doesn't like the way I use keywords. I swear I didn't plan this. Because I echoed done without quotes around it, it's yelling at me because it knows that done is a bash keyword. It's telling me to put quotes around it. It's not super dumb. I'm not complaining about shell check, but it's really funny. The times I end up fighting it are times like this. I promise you, I did not plan this. This was totally organic. That's really fun. But look at this. Hey, this is a really nice message. That's awesome. I really like this. This can find it. So if you want, I would say use shell check if you're during during development work, stuff like that. Bash minus U, also super useful. If you want this this behavior, you can get it on a per variable basis without having to set minus U. You can do this expansion where you just put a question mark here, and this will expand the variable only if it's set. So on this per variable thing, I don't know how this works in other versions. We can test it, but same exact thing here. You can see parameter not set. If we run this, hey, that's really awesome. I don't know how far back this goes. You're probably safe to use something like this. I personally wouldn't. If I'm checking these things at runtime, I'm just going to check them at runtime. Like that's how I would do it. I would just check -z or -n to see if they're set or not. But this is a cool way of doing it per variable. Definitely really useful, especially if you're running like a runoff script or something. You just want this in there. Yeah, I would say go for this. All right, so we got the last thing here, the IFS line. And like I said, this one was a little bit new to me. This one was surprising to me. I'm going to say that one. This was surprising because I had never really seen this or encountered this. They are manually setting IFS, the internal field separator, to a new line and a tab. If you know by default in Bash, the IFS is set to space, new line, tab, all three of those characters, and there's special meaning about how words are expanded based on this. So let's pull this up and let's take a look at what we got. We got our simple script right here. We have an array here of hello space world. You suck space at programming, a whole bunch of spaces here. We have an array with 3 elements. The 3 elements have white space in them. One has 1 space, one has 3, and one has like 5 or 6. I don't know. I'm not going to count it. This is how they show it in their example. 4 item in array, echo item. There are no quotes here. This is hurting me to look at. It's fine, but there's no quotes around array here, and there's no quotes around item here. So let's see what happens when we run this without quotes. So you can see we break them all on their white space. So we have hello world, you suck at programming. Each one of these was handled separately. That's not good. That's not what we want. So we can see if we use the strict mode where we set IFS to new line tab without putting the white space in here, and we have everything else exactly the same, unquoted variables and everything, we run the strict mode and we get what we want. That's pretty cool. I have to say, when I first saw this, I was like, that's a pretty cool little trick right there. I just worry about the ways this can break. Let's talk about some of the ways this can break. First, I want to jump into this. I want to just show my simple example at the beginning. If you just put quotes around it, this fixes the issue too. You just have to remember to put quotes around your expansions. You have to put quotes here because you're expanding a variable or an array. You have to put quotes here because you're expanding the data inside the array, the item of the array. So as long as you quote your variables, it works. It works exactly the same as the first strict example worked. We get the exact same output. Let's talk about some of the ways it's broken. Hello, new line world. You tab suck at space programming. If we use the strict mode here and we don't quote the variables, obviously it's going to work sometimes, it's going to break. It's going to break when there's a new line, it's going to break when there was a tab, but it's going to work when there were spaces. That's not great because in this example, yeah, I'm setting the array myself, but you could imagine this comes from some sort of user data. Maybe these are file names. It's not normal that you encounter file names with new lines and tabs in it, but you can. There's nothing that says they can't be there. Maybe some modern POSIX standards, I think, say something about that. But regardless, it's totally valid. I could put new lines and tabs into a file name. It's weird, it's gnarly, but you can do it. So you can break it that way. And then let's talk about this. Here's a syntax that I really like for parsing files in Bash. This is strict mode enabled. We do a while read, and then we have name and URL. So we read 2 fields, and we're going to echo the name and the URL from data.txt. I will show you what's in data.txt. It's a simple text file of name space URL. So if we run, which one was it? Was it 04? I already forgot. Okay. If we run 04, we can see that we get name equals Dave space daveready.com, comma, URL equals nothing. That's not good. That's not right. What we wanted to have happen was what's in 05. We have the exact same logic here, just without the strict mode, without the IFS being set there. We run this and we get name equals Dave, URL equals this. So this is not great. It's not fantastic. Sure, you could work around this. I could just put like ifs equals this here, so it'll only last for the read command. You probably should be doing something like this if you're reading a file, but I just wanted to showcase weird ways that this could break. If you start putting this stuff in your bash scripts, it's going to break in ways that you might not be prepared to deal with. I say that if like a beginner, I know a lot of people are like, hey, I'm just starting to learn bash. Should I be using the strict mode? Or hey, I'm in bash, I'm using the strict mode and it's breaking. It's like, I'm so sorry if it's breaking. It's going to be very hard to debug. It's already hard to debug sometimes, bash scripts. This, I think, makes it harder to debug. That's a shame. The blog posts, I mean, I read the blog post. I can see, I kind of, I'm going to project a little bit. I could be totally wrong, but I kind of get the feeling some of this was written in anger, and I completely get that. I completely get that. As someone who loves bash, I can completely respect that. And the idea here is unless you love debugging. So it's meant to limit the amount of debugging you do. And here's what I'll say about it. I think if you're, like, let's say you're a beginner and you're learning this, I think without this strict mode, you're going to encounter bugs like 70% of the time, and 30% of the time your script's going to work. That's eager. You're going to encounter bugs 90% of the time, and 10% of the time your script's going to work. With strict mode, your script might work 90% of the time, and 10% you're going to encounter those bugs. But those 10% bugs that you're going to encounter with strict mode enable, it's going to be very, very hard to debug. It's going to be very hard to look up answers to. I would worry about the person trying to debug that. That's my concern here. I think this might actually limit some of the bugs you encounter, but when you encounter bugs with this, it's going to be harder to debug. So that's why I would personally stay away from it. These are definitely some of the gotchas, some of the pitfalls you can encounter with it. And yeah, those are my thoughts on bash strict mode.